So today I'm going to share some of the topics related to probability. Basically, probability works. So probability is basically what you say, the possibility of happening any event. you know, Let's say happening an event. Let's say if I want to uh, test the probability of either it will come head or tail in a coin, in a fair-sided coin. So there are 50% chances of coming head, or we said head is one possibility and tail is another possibility. And total possibilities are two. So this total possibility is basically sample space, and probability is like whatever event I am focusing on. Right now, I'm focusing on head. So head is one event out of these possible two, and total events are two. So it is going to be 0.5. So based on that, if I want to derive definition of probability, so it would be probability equals to um, desired outcome divided by total sample space. A sample space in this case of coin would be head and tail, all the possible events will. So similarly, the probability of tail would be 1 upon 2 because tail is one event, the total are 2 or 0.5. And if I add both the probabilities of head and tail, so it would be 1 upon 2 plus 1 upon 2 and it would be 1. So it means the total probability is always 1. So let's just pass it on to, you know, dice. The dice if you play Ludo, the dice basically has 6 sides. Face-sided die means all the dimensions are equal. So we can have 1, 2, 3, 4, 5, and 6. Let's say I want to find the probability of number 1. So 1 is one of the event from the 6. So the desired outcome is 1. The total sample size or the total possible events are 6. So 1 upon 6 is the probability of 1. Similarly, 1 upon 6 is the probability of 2 because 2 is only single event. Similarly, 1 upon 6 for 3, 1 upon 6 for 4, 1 upon 6 for 5, and 1 upon 6 for 6. So all individual events have their probabilities as 1 upon 6. So let's say if I want to add all these probabilities of 1, 2 till 6. What I'm going to do, I'm going to add 1 upon 6 times. Okay? 6 times. 6 times means 6 times 1 upon 6 is going to be 1. So total probability is 1. So now we have identified the individual probabilities are the desired outcome divided by the total outcome. So probability of 1 is 1 upon 6. What about probability of not coming 1? Not coming 1 would be 1 means total minus probability of coming 1. So it means it would be 1 minus 1 upon 6. So it would be 6 minus 1 upon 6 and it would be 5 upon 6. So if probability of coming 1 is 1 upon 6, the probability of not coming 1 is 5 upon 6. Similar is the case for probability of not coming 1, sorry 2 is 1 upon 6 and so on for 3, 4, 5 and 6. So this is how we are going to calculate the probability of not coming that event. So probability of not coming that event is basically the complement event. This is basically a complement event. Yeah? And let's just move that to what do you say? Uh, mutually exclusive events. They are part of the independent event. Huh? Mutually exclusive events. Mutually exclusive events are written as basically this way. These A and B are two events. It means one event, both events can't happen at the same time. Can't, they can't happen at the same time. There has to be some different timing for both of them. So in a dice, you can't have one or three simultaneously. No, not possible. You cannot have that. Okay. Either you will have one or either you have two. So either you can have probability of 1, which is 1 upon 6. We have recently calculated, or probability of 3, 1 upon 6. So they can ask, find the probability of either getting 1 or 3 in a dice. So this is a case of basically mutually exclusive event. You know? And let's say in our case, probability of 1 is event A, probability of 3 is event B. So probability of either one. So let me just write it in the form of a formula. Probability of either 1 or 3. So it's going to be probability of 1 plus probability of 3. So this is going to be 1 upon 6, and this is going to be 1 upon 6, and this is going to be 2 upon 6, 1 upon 3. So probability of either getting 1 and 3 is going to be 1 upon 3, and this is a case of mutually exclusive event. Now just let's discuss mutually inclusive event. Mutually inclusive event means, first of all, it is written this way. Intersection. So A intersection B is the commonality, commonality between both the events. So let's say you have a deck of cards. First of all, let me explain it very briefly. So deck of cards have 52 cards. 4 suits are there. 4 suits are basically heart, diamond, club, and spade. These are red colored cards, and these are basically black colored cards. Now let me write it with black. Okay. So all suits have 13 cards in total. So it starts from ace, which is also referred as 1, but we write it ace, and it has a king, it has a queen, and it has a jack. Similarly, for diamond, we have ace, we have king, we have queen, we have jack, ace, king, queen, and jack for club, ace, king, queen, and jack for spade. So these are the 4 cards, and then 2, 3, 4, 5, 6, 7, 8, 9. So basically, if you count them, these are 2 to 9, sorry, 10 also. So 2 to 10 are 9 cards, and then 10, 12, 11, 12, 13. So 13 cards in each category. Similarly, this repeats for this also. Let's make it 10. And let's make it total till 10, and total cards are 13. Okay. And let's just make it 13. So 13 for all. So now let's understand mutually inclusive events by, so these total are 52. So let's understand mutually inclusive events with the example of, deck of cards. So let's say we want to find the probability of picking, say, red card and either red card or king. Getting this? So red card or king. So red, if I talk about red card, so red is heart, red is diamond. So we have 13, 13, 26. The probability of having red card is 26 over total 52. And probability of king, basically. is within the red card there are two kings. Yeah. Sorry, overall probability of a red card is 4 upon 52. Getting this? Overall probability of king is 52. But if you see the two red cards, because if I'm selecting the king, I can have this club and spade also. Okay, so but if I'm selecting the red card, I have king and king in both the red categories. So if you see king for heart, king for what do you say, diamond, are already included in this 26 upon 52. This line and this line. Huh? And then we have included this 4 upon 52. So when we are putting this, in that formula, I'm just writing the formula again. PA intersection union B, PA plus PB, P of B minus P intersection B. So let's say this is the red event, this is the king event. So probability of getting red, probability of getting king, and probability of red and king. We have to first find probability of red, which is 26 upon 52, or 1 upon 2, on probability of king, which is 4 upon 52, or you can say 1 and 13, and probability of red intersection king. So basically, there are two kings which are red also, heart and diamond one. Okay, so they are 2 and 152, 1 upon 26. So I have to put the values in the formula. So 1 upon 2 for probability of red, and 1 upon 13 for probability of king, and the common one 2 upon, sorry, 2 upon 52 means 1 upon 26. So let's make it 1 upon 26. If I take LCM of all of them here, that will be 26. 2 13 times 26, it will be 30, 2 and 2. So 2 and 2 would be cancelled out. 13 upon 26 mean 1 upon 2. So 1 upon 2 is the probability of either getting, picking red card or king. So this is how, mutually inclusive thing works. So what is inclusive in it? The king element is inclusive because king is included in the category of 26 upon 52, which is the red, and king is included in this king category also, because there are four overall king. This 1, 2, 3, 4. That's why we have to subtract it. Two are repeated basically. This and this are repeated again. So we have to remove them. So this is the common element. So this is inclusive. Although they are, they cannot happen at the same time. Still, two elements are those because we can have a red and a king. They are included in it. So we have to subtract them. So this is how it works. So let's keep it there. Inshallah, I'll discuss some more topics in the future. Take care. Assalamu alaikum.